So you want a new AI agent engages with your online users and addresses their queries sensibly using information that are already there on your website. Instead of having your users search through pages and pages of your website for their answers, users can now ask the AI agent and boom, questions answered right away. Clever, right? You can set up your own AI agent to do just that. Yes, you heard it right. So follow me as I show you step by step.
All right, let's begin. The goal is to have an AI agent on the website that handles online user inquiries by leveraging the knowledge base built upon the website contents. To get there, first, we need to set up secure data connection from AWS S3 and configure Data Cloud to process and index the unstructured data it receives from AWS S3. Next, we set up an AI agent to answer questions based on information of these unstructured data and deploy the AI agent to the website. Finally, we set up the automation for feeding the website contents to Data Cloud via AWS S3. This diagram shows how the different pieces of the puzzle come together to bring this solution to life. At the core of it, it's Salesforce Data Cloud for vector database and for AI agent development. Integration middleware pulls the website contents in PDF, text formats into AWS S3 data staging. And later, these files get transferred to Data Cloud. At Data Cloud, search index vectorize the unstructured data in vector database for semantic search later. At the website, as soon as the AI agent receives an inquiry from the user, the agent action and prompt template kick in. First, it performs semantic search on the unstructured data to find any information that are relevant to the inquiry. Next, the user's inquiry, supplemented with relevant information from the semantic search, are then forwarded to the large language model of choice to generate the final response to the user. This mechanism is commonly known as retrieval augmented generation. In first activity, we need to generate a digital certificate to secure the connection between AWS S3 and Data Cloud. I've installed the OpenSSL Toolkit. Check out the description below for a link to download the installer. Now, I'm launching into the PowerShell command line terminal, changing the working directory to the temp folder. This is handy to keep all the files needed at one place. Now, create the private public key pair. Next, create a digital certificate using the key pair from the previous step. Complete the questions as prompted. Now, create a PKCS8 private key using the key pair from the previous step. You should now have these 3 files in your folder. Keep these files, and we'll need them later in the setup. Oh, by the way, if you open the private key file, it should look something like this. Now, logging into the Salesforce developer environment. At the gear icon at the top right, bring the Setup menu. Type in App Manager in the Quick Find box to take you to the App Manager. Click New Connected App button to create a new connected app. Fill in the required information for the new connected app. We'll name it AWS S3 Ingest. Think of connected app as a credential for AWS to identify itself for legitimate access to Data Cloud. Check to enable OAuth settings. Now, we need to get the callback URL. I've opened a notepad to keep track of all the setup parameters at one place for easy reference. Extract your Salesforce org URL from the URL domain name. Coming back to the callback URL, remember this. It's your org URL, followed by services/OAuth2/ and callback. Note down the callback URL because we will need it later. Moving on, check Use Digital Certificate and upload the digital certificate file generated earlier. Look for the file with extension CRT. Next, we need to define what scope or permissions are granted for AWS when it accesses Data Cloud. In this case, AWS needs only 3 scopes. Manage data, cloud ingestion, API data. Manage user data via APIs. Perform requests at any time. We leave the rest as default. Click Save to finish. Now, enter OAuth in Quick Find box to get to OAuth setting page. When you see the Allow OAuth username password flow, flip the toggle to turn it on. Now, go back to the App Manager. Look for the AWS S3 Ingest Connected app created earlier. Select Manage to proceed. Click Edit Policies. Enforce IP restrictions is enabled by default to ensure access from external is permitted for specific origin IP addresses. For this demo, we relax IP restrictions so that access to Data Cloud is allowed as long as the AWS access is authenticated. Click Save to continue. Now, return to App Manager. Locate AWS S3 Ingest Connected app again. Select View. Inside AWS S3 Ingest Connected app, look for Manage Consumer Details button. Click it to proceed. Before the consumer details can be revealed, authentication is required. Verification code is sent to your email address you registered with the Salesforce developer environment. Enter the verification code to proceed. Upon successful authentication, you will see the consumer key and consumer secret of this connected app. Note down both the consumer key and consumer secret, as we'll need them later. For the next step, open a new browser tab. Reason being, we'll need to construct this unique authorization URL. Invoke the URL from the new browser tab as part of the process to authenticate the connected app with Data Cloud to allow AWS to send S3 file change notifications later on. Now that we've constructed the authorization URL, we're ready to invoke the URL from the New Browser tab. When you see this page, which Salesforce prompt you to allow access, click Allow, and you're good to complete. Before getting to the setup in AWS, we need to download a serverless application template from this GitHub link. I'd recommend you check out this comprehensive documentation if you're curious how it works. Now, go to Code button, click and select Download Zip to download the template. Locate the zip file. In my case, it's downloaded to my temp folder. Next, unzip the zip file. In the folder extracted from the zip, locate the file template YAML. Open the template YAML to edit it. Find in the file a section which has parameters such as client ID, username, login URL, and RSA private key. We want to update the client ID to be the client ID of the connected app we created earlier. So what I'll do, I copy and paste the client ID I kept in the notepad. Now, update the username to be the Salesforce login ID of your Salesforce environment. Leave the login URL as it is. Now, we will update RSA private key, but it's a little tricky. Let's locate the private key file we created earlier. Yep, that's the one. Open the file, and you will see the long, private key string. We need to encode this entire string into base 64 format. Let's copy the entire private key. Next, we use a base 64 encoder like the one on this browser tab to encode the private key string into base 64 format. Voila! Bob's your uncle. Now that we have the private key in base 64 format, copy it. Back to the template YAML file. Update the RSA private key parameter with the base 64 encoded private key. Save the file and close it. Now, locate the AWS folder where the template YAML file resides in. Zip it up. Okay, done. Now, log into the AWS environment, which I've created beforehand. At the bottom left screen, locate Cloud Shell button and click it to open. At the right of Cloud Shell console, click Action button and select Upload File. Select the AWS zip file we created earlier to upload it to Cloud Shell. After the AWS zip file is uploaded successfully, enter the command on the console to unzip the file. Change the working directory of the Cloud Shell to the AWS directory extracted from the zip file. Enter the command to build the serverless application template. Phew! Enter the deploy command to deploy the template. This will guide you through the deployment. Answer the guided questions to complete the deployment. Excellent. Now we're done with the Cloud Shell. Close it. At the search bar, enter IAM to take you to the IAM services. Inside the IAM, select Users. Click Create New button to create a new user. We will name this S3 API User 01, then click Next. Leave the rest as default. Click Next. Click Create User button to finalize. Nice! The new user is created. Click into it. Click Add Permissions button and select Create Inline Policy. In the Policy Editor, select S3 as the resource which the policy is applied to. Now, define the explicit allow for these specific permissions on S3 resources. Once these are defined, click Next to continue. We'll name this new policy S3 API Restricted 01. Click Create Policy to finalize. Great! The new policy is created and attached with S3 API User 01. Click Create Access Key to proceed. On the next screen, select Other and click Next. Give a tag and click Create Access Key button to finalize. Nice! The AWS Access Key and Secret Access Key are created. In case you were wondering, this is the credential used by Data Cloud later for secure access to AWS S3. Keep both the Access Key and Secret Access Key in the Notepad for reference. At the search bar, enter S3 to take you to the S3 services. In the S3 section, you will notice a bucket named Our 8G Data Cloud Unstructured is created when we deployed the serverless application template from Cloud Shell. This S3 bucket will serve as the staging area for website content files to be transferred to Data Cloud. So, remember the bucket name and note it down in the notepad. Okay, now that we've successfully set up the secure connection at AWS S3 in our first activity, we're ready to move on to the next activity. Back in the Salesforce developer environment, click on the gear icon at top right of the screen and select Data Cloud Setup to take you to the Data Cloud Setup page. Select Other Connectors on the left. Click New to create new connection to Data Cloud. On the next screen, select AWS S3 connector. We name this unstructured FAQ S3 connection. We will copy the AWS Access Key and Secret Access Key from the notepad. Likewise for the bucket name, copy the S3 bucket name from the notepad. Now, let's test and verify the connection to AWS S3 is established OK. Then, click Save to finish. At top left of the screen, click App Launcher, enter Data Cloud to take you to the Data Cloud app. We need to map the unstructured data from S3 connection to Data Lake Object and Data Model Object at Data Cloud. This is the prerequisite for vectorization of the data. Select Data Lake Objects tab. Then, click New to create new Data Lake Object and new data model to be mapped. Select from External File option, specifically Amazon S3. Next, specify the unstructured FAQ S3 connection we created earlier. Configure the file name pattern such that any file that lands on root directory of the S3 bucket will be processed and mapped in Data Cloud. Let's name the Data Lake object and the corresponding data model object unstructured FAQ. Leave the rest as default for search index to be created automatically. Click Next. Okay, looks good. Click Save to finalize. Now, we go to Data Explorer tab to inspect the new data lake object and data model object we just created. The unstructured FAQ data lake object and data model object are empty. That's because we have not put any file in the S3 bucket. Let's do a little experiment. I open a new browser tab to bring up the web page of a travel insurance product. It has a comprehensive write-up about the product, such as the overview, key benefits, and FAQ. These are useful as the knowledge base of the AI agent to answer users' inquiry pertaining to the travel insurance product. Let's save a copy of the web page in PDF format. Now, go back to the Browser tab of AWS. At the S3 bucket named RAG Data Cloud Unstructured, click Upload. Upload the PDF file we just saved. Okay, the file is added to the S3 bucket. Back to the Browser tab, which we have the Data Cloud Data Explorer. Let's inspect the Data Model Object Unstructured FAQ. We should see the uploaded travel insurance product PDF file is mapped in the Data Model Object. Nice! This concludes the setup at Data Cloud to receive the unstructured data from S3 connection. Let's move on to the next activity. If you recall, we opted for the search index to be created automatically by Salesforce. Along with that, a retriever was also created to retrieve relevant data from the vector database to augment an AI prompt. In Einstein Studio, the unstructured FAQ retriever is created for us. Select Open and Prompt Builder option to proceed. We want to configure a prompt template to be used by the AI agent later to make use of the retriever to return the relevant data from those unstructured data. We name this prompt template Insurance Inquiries and give a meaningful description. Click Next to continue. In Prompt Template, this is where we give specific instructions on how AI agents should do and shouldn't do while handling certain question or action falling within a task scope we defined. It's like cooking recipe. So I copy-paste the prompt I prepare beforehand. Be very specific about the role the AI agent takes on, the what, and the how when it handles user inquiry. I bet you notice two things that stand out: the placeholders of question query and search results. To ensure the prompt template will prepare its response based on the specific query from a user, we map the placeholder with user's query as the input. Notice that we also map another placeholder to unstructured FAQ retriever, so that the relevant results from the unstructured data are supplemented to the prompt for large language model, or LLM in short, to form the appropriate response to the user. On the right panel, we need to configure the retriever to search relevant results based on the user's query, the output, and number of results. On the template properties, we specify the LLM best suited for this prompt. We're good to save the prompt to test it. Calibrate if necessary. We test the prompt with a question what a user would normally ask about the travel insurance, and specify the chunks returned from the unstructured FAQ retriever. We did test, and the prompt is working fine as intended. It provided an accurate response based on the information found from the unstructured data we uploaded to S3 bucket. Okay, we're good to activate the template. We go back to the Salesforce setup menu. Now the exciting part, we're going into the setup of the AI agent. Enter agent to take you the agent setup. Click New Agent to create a new agent and follow the steps to configure. For the sake of this demo, we uncheck all the topics and click Next to continue. We need to fill in the required information. Notice that the fields are pre-populated, such as the name, description, and role. Name this agent Customer Ambassador and fill in the description, role, its company. Check the option for Enhanced Event Log. Click Next to continue. Click Create to finalize. We need to define the topic the AI agent works with in its scope of work. On the left, click New button, then click New Topic to proceed. We name this new topic product Q&A. Notice that the fields are pre-populated for you, such as classification description, scope, instructions, and so on. We'll update them accordingly. Okay, click Next to continue. We skip the action, cause will define the action later. Click Finish to finalize. Notice the product Q&A topic is successfully created. Click Edit to continue. Select the tab, This Topic's Action. Then click New. Create New Action. The action type is based on the insurance inquiries prompt template we created. Follow the following steps to configure the action. Take note, for the input chunk parameter, we need to copy the handler for the return chunk of unstructured FAQ retriever from the earlier setup. Okay, click Finish to finalize. We'll add one more instruction under the topic to instruct the AI agent to use the newly created insurance inquiries action to prepare a response for insurance-related inquiry. Nice. Now that we have the AI customer ambassador set up with the topic in action, let's test out how well it handles the questions. Cool. The AI agent is working fine as intended. What's more, in Agent Builder, we can expand the center pane to view behind-the-scenes conversation details that describe which topics, actions, instructions, and reasoning the AI agent used to answer the question. This makes troubleshooting easier if you notice the AI agent is not functioning properly. Let's test the AI customer ambassador with another question. Okay, I am convinced the AI customer ambassador is working okay. We'll go ahead to activate it. And this wraps up the AI agent setup in this activity.
That's it for this video. Join me in part 2 to see your AI agent engages with website users. If you enjoy the video, please give a like. Ciao now.